Phylogenetic Tree by Dakota and Giovanny. Today we're going to talk about the basics of phylogenetic trees and cladograms.
Classification basics. Each level has certain similar traits that all relate together. As you go down each level of class, you get more specific on the traits that are similar until you specify a certain organism. For example, a leopard, the domain will be Eukarya, kingdom will be Animalia, phylum will be Chordata, class will be Mammalia, order will be Carnivora, family will be Felidae, genus would be Panthera, and species would be Panthera pardus.
Cladograms. Cladograms are a diagram depicting patterns of shared characteristics among species. When reading a cladogram, the first animal on the left is most likely an outgroup, which is an animal with little or no relation to the rest. Each animal to the right will have a trait that the one before it didn't. The notches in between the animals represent the trait present in the animal to the right of it.
Phylogenetic tree basics. A phylogenetic tree is a type of cladogram that represents evolutions and the time/order each organism splits from one another. A phylogenetic tree orders the different evolutions based on the time they appear, while a cladogram organizes it by traits similar amongst organisms. Timing and changes in DNA are used to make a phylogenetic tree, as they show the time organisms split apart and their DNA is mutated to create a new organism.
How to make a cladogram. When making a cladogram, first you find the outgroup, which again is the animal with the least amount of the specified trait. Then you put the animal with the second least amount of traits and put it on the next branch. Then you would write the new trait found in that animal, and you would repeat the process until you've used all the animals on the chart.
This method is used because the principle of maximum parsimony states that you should first investigate the simplest explanation that is consistent with the facts, and cladograms show the difference between animals and when a trait might have developed. Take an example, this chart of organisms. First you start with the lamprey, which has none of the organisms, and you have to put it at the beginning. Then the shark comes in. You put the shark as the first organism to have one trait. Since it's the first trait to develop was jaws, you have to put the jaws before the organism to state that's when the trait has developed. Next, you have to put the salamander. Since the salamander has jaws and it has developed lungs, you have to put it after the shark. And since the lungs developed before the salamander came, you have to put it between the shark and the salamander, since some organism developed the lungs to evolve into a salamander. Next, the lizard comes into play, and the lizard has jaws and lungs and amniotic membrane. So the amniotic membrane has to come before after the salamander, before the lizard, since the organism might have developed it in between. And then the tiger comes in, and the tiger has developed hair, or some organism between the tiger and the lizard has developed hair. So the hair will go there, and the tiger will go next, since it has hair.
And then you would just repeat the process.
And so on with the gorilla and the human.
Thanks for watching.
Thanks for watching, guys.